So electrophilic addition to alkenes is the entire next chapter, and we're starting it barely before this exam. And the nucleophile on every one of these reactions is a carbon-carbon pi bond. That's the common denominator between all of them. The electrophile is going to vary, and we're going to do different types of electrophiles, but we'll always be adding it to this carbon-carbon double bond. First, we're going to start with the electrophile as being a strong acid. And anytime you add a strong acid to an alkene, you mix that nucleophile-electrophile pair together, the intermediate that they will give you is a carbocation. Okay, so consider the following reaction where we have HCl, a strong acid, and the bond dipole favors chlorine, where the chlorine's electron rich and the hydrogen is electron poor, where the hydrogen is the electrophile. And so now the alkene or the nucleophile will attack that hydrogen, right? Nucleophile pushes electrons towards electrophile, and the chloride must leave, or the hydrogen must lose its old bond if it gains a new one. Right, so you guys have learned now that the carbon in the center here is tertiary, or it has no hydrogens attached initially. And so if the hydrogen adds to this end of the pi bond, then the carbon in the middle is going to be missing or go without the octet. So that's an electrophile. The other